Hello, chemistry students. Today you're going to learn about states of matter and phase changes. Okay, states of matter. We're going to talk about solid first. Molecules are very close together. And you know what? We're going to use the example of ice. Okay, because ice is a solid water. These molecules are very, very close together. They have a definite shape and a definite volume. An ice cube right here, let's pretend this is an ice cube. It's in the shape of a cube, and the volume, you can measure it and it doesn't change until it changes from a solid. It is very restricted in motion, rotation and vibration only, so these molecules are just moving like this. They're not moving around like this. High density, it's because the molecules are packed very closely together in a small volume. They are not compressible, or they are incompressible. You can press on an ice cube or a solid as much as you want and it will not change its volume. It does not expand much with an increase in temperature. Now we're not talking about melting, okay? When it's a solid, negative 100 degrees, and you warm it up to negative 50 degrees, it's still going to be a solid and it will not expand much. The diffusion is so slow you can hardly notice it. So if you have two ice cubes together, one's red and one is white, the red is not going to diffuse into the white where you notice it. Okay, the next one, liquid. So now we're going to talk about liquid water, the liquid that you drink. The molecules are very close. They're still very close together. It takes the shape of its container. So if it's in this beaker, it will take the shape of a beaker. If you spill it out, it'll take the shape of the floor. It has a definite volume. Whether you have it in here and it's 20 milliliters in the beaker, once you spill it out, it will still be 20 milliliters. There is a limited freedom of motion, and there is some degree of fluidity, which means that it can move. They do move. Medium high density, it's less than that of a solid, except for water. Okay, it is somewhat compressible, and what that means is if you put some pressure on this water, it will compress a little bit and change the volume a little bit, but not much. Expands slightly with increase in temperature. So if we put some heat on here, it would expand, and it diffuses easily but less rapidly than a gaseous state. So if I put a drop of food coloring, liquid food coloring, in some water, it will eventually diffuse through. Okay, so now let's talk about steam, a gas. As you can see, the molecules are far apart. They are not touching. It takes the shape of its container, and it takes the volume of the container. So its volume does change. Whatever the volume of the container is, the volume will be of the gas. For instance, if I put some steam in our room, it will take the shape of the steam container that it's in, and then I spray it out. Then it will then take the shape of the room. They are free to move in all directions, has a high degree of fluidity. It's a low density because there aren't as many molecules packed in a certain space. They are easily compressed into small volumes because there's a lot of space in there, so you can compress them. They're highly expansive with increased temperature. So you increase the temperature on this gas, and they're going to have more space between them. They diffuse easily and quickly. So you can think about if I spray perfume on one side of the room, it won't be long, and the perfume, people will be able to smell the perfume on the other side of the room. Now I'd like you to pause the video and do example 3. Okay, I've underlined hints that told me that this was a gas. All right, now let's talk about phase changes. I don't know if you've ever heard of plasma before, but if you have not, all plasma is an ionized gas. So you add energy to this gas, you ionize it, and it turns into a plasma. So going from a plasma to a gas is deionization, and this is like turning off fluorescent light. all right? Because in the fluorescent light there's a gas, and when you turn it on, that electrical energy goes to turning it into an ion, and it turns into a plasma, which is what you see. Going from a gas to a plasma is ionization, and that's like turning on a fluorescent light. Now let's talk about going from a gas to a solid. Going from a gas to a solid is deposition, and this is like frost in the winter time. The water in the air freezes onto the leaves and makes frost. Going from a solid to a gas is sublimation, and that's like dry ice. From a liquid to a solid, you should all know, is freezing. That's like making ice. Going from a solid to a liquid is melting. Now going from a liquid to a gas is vaporization. It's like boiling water. And then going from a gas to a liquid is condensation, like the water droplets on the leaves. Okay, on our phase changes, you need to know the difference between endothermic and exothermic. Endothermic takes in heat, heat enters the system. Exothermic releases heat, heat exits the system. So let's go back up here to endothermic. It requires heat to make that change. So it's going from a low energy to a high energy. So you need to think about whatever goes from a low energy to a high energy is an endothermic reaction when the phase change is going on. So let's take water to steam. That's going to be endothermic because you have to add energy to the water to make it steam. Okay, exothermic. That would be water to ice because it releases heat. You take some water, you need to take some heat away from that to make the ice. Go ahead and practice examples 4 and 5 and pause the video. Here are the answers. For exothermic, heat is released. You have to take heat out in order to do these things. Endothermic, heat goes in. You have to add heat in order to do these things.